All right, so final unit. This is 10A, and let me go back there real quick. We're interpreting key features of graphs and tables. So you've kind of done this before. If you look at this graph, it should look somewhat familiar. Um, if you were to kind of tell me what was going on with this red here, you should be able to tell me that from 0 minutes until 4 minutes, there was a constant rate of acceleration. And then from 4 minutes to 7 minutes, so from in this area here, the speed remained constant because this is the speed in miles, meters per second, miles per second. I'm not sure which one it is, meters per second, I'm assuming. Okay, so the speed remained constant here. And then from 7 to 10, there was a constant deceleration. So maybe that's jogging some memories. If not, don't worry too much about it. Let's look at this first example. So we've got Dobbs racing Cicero, and we've got this graph that's going to help us answer the questions. So the first part of the question is, what is Cicero's rate of change for the first hour? Well, if you go down here, it has his time in hours. So we're looking at from here to here. So we've got this point, because Cicero is the purplish blue, and there. Okay. So you've got 0, 0, which is this point down here. And you have 150, which is this point here. So it's asking for the rate of change. So hopefully you remember that rate of change is y1 minus y2 over x1 minus x2. If you don't, write that down right now. So I'm going to start off with 0 minus 50. So I'm going to do the y's first, and I'm starting with that 0, which means when I do my x's, I'm going to have to start with that 0. So I'll do 0 minus 1. So remember, whatever you start with for the y's, you have to start with that same part of the coordinate pair for the x's. So that's going to give you negative 50 over negative 1. The negatives cancel out, which is 50 over 1, which simplified is 50 miles per hour. Okay. So that would be the answer to the first part of the question. After biking for a while, Cicero stopped to take a rest. How far from home was he then? So you've got to look at Cicero's, which Cicero, again, that's the purple there. The stopping to take a rest, this is distance now. So that means that if this is 50, he, for the first hour, or for the second hour, from 1 hour to 2 hours, he didn't go any further. So that would be him stopped and taking a rest. So how far from home was he? Well, if this is 50 and he's leaving from home, he would be 50 miles from home. And how long was the rest? We determined that it didn't move for the course of 1 hour, because from here, 1 to 2 is 1 hour. So 1 hour or 60 minutes, whichever you want to write down. All right, the final two parts. Approximately how far from home was Cicero when Dobbs caught up? So Dobbs is in red, and they caught up right about there. All right, so pretty close to, in between like 50 and 60, I'd say. Well, 50 is right here, so in between 50 and 60 is where Cicero actually, or Dobbs actually caught up to Cicero. So we're going to round up. We're just going to say right about here. So at about 60 miles is how far they had gotten when Dobbs caught up. Again, be careful. They're not asking for how much time had passed. They're asking for how far from home. So pay attention to what they're asking in the question. And then how far ahead is Dobbs after 3 hours? So you go to 3 hours, and okay, here's Cicero at 80 and Dobbs at 100. So the difference is 20 miles ahead. Now notice this little thing here. Those 3 dots, whenever you see that, that means therefore. Okay, so you want to actually put that there. Say, okay, Dobbs is at 100 miles, Cicero is at 80 miles. Therefore, Dobbs is 20 miles ahead. So use that little symbol there, okay, when you're answering these questions. Let's take a look at another one. Anna is racing Elsa. Okay, what is Elsa's rate of change from hour 3 to hour 5? So now you've got to look at Elsa, which is, again, the bluish purple. Okay, in hour 3 to hour 5. So we've got our points 340 and 5 100. Okay, so again, remember y1 minus y2 over x1 minus x2. So now I'm going to start with the 100 and subtract 40. And since I started with 100, I'm going to start with 5. Do 5 minus 3. So 100 minus 40 is 60. 5 minus 3 is 2. So 60 over 2. So you have that. It simplifies to 30 miles an hour. So after biking for a while, Elsa stopped to take a rest. How far from home was she then? So Elsa, again, is in the blue. And she stopped between here. So if we go over, because it's asking how far from home, this is 40. So she was 40 miles from home. And how long was the rest? Well, this space here, that's from the second hour to the third hour. So 3 minus 2 is 1 hour, or you could write 60 minutes. Approximately how far from home was Anna when Elsa caught up? Well, Anna's in red. Elsa's in purple. They caught up right there where they intersected. All right, so if you take that over and you look, they were approximately 60 miles from home. How far ahead is Elsa after 5 hours? Well, here's 5 hours. Elsa is at 100. Anna is at 80. So Elsa's at 100. Anna is at 80. Therefore, so there's that symbol again, Elsa is 20 miles ahead. Okay? So hopefully this all makes sense. Basically, these questions are going to have 4 parts. They're going to be 4 very similar parts. Make sure you have notes on both examples. And that's it. All right. Have a good one. Look for the next video.